Samy Kamkar is a reverse engineer interested in building hardware and software, exploiting unusual properties of everyday systems. In his talk today, Samy dives into producing glass pendants containing glowing breath without LEDs or electric wire. Or ELs. Please welcome to the Hackaday Supercon stage, Samy Kamkar.
Thanks. Hi, everybody. Awesome, thanks. Great to see everyone. I love Hackaday. Let's see if I can figure this out. All right, cool. So when I was 10 years old, my mom spent everything she had to get me this computer. This was the best day of my life. Immediately, because she was going to university, I was able to dial up into the university, get on the internet, and immediately I did what anyone would do, and I searched for the X-Files. And I wanted to chat with people about the X-Files, so I found something called IRC, Internet Relay Chat. I downloaded IRC. Yeah, you guys know IRC. I downloaded IRC. I went into a chat room and I said, who wants to chat about the X-Files? And someone immediately said, get out. So, whoa, we can try to chat about something else. Like, what's your favorite TV show? And they said, you have 10 seconds to get out. And I was so confused by this. And I remember, I'm like, should I be worried about this person? And I remember my mom told me, don't ever give out your name. And don't talk to strangers on the internet. I saw this tweet recently. Don't get in strangers' cars and don't meet people from the internet. Today, we literally summon strangers from the internet and get in their cars. And I was thinking, well, back then, I didn't actually give this person any info, so they can't do anything to me. I'm invincible. So I said, no. 10 seconds later, the brand new computer that my mom spent everything on did this. I got a blue screen of death. This is 1995, running Windows 95, and I freaked out. I pulled all the wires out. I turned off, I pulled them away. I waited 20, 30 minutes. I figured the longer you wait, the better it'll be. It'll heal. And I plugged everything back in. And fortunately, everything came back up. But with the adrenaline just rushing through my veins, I thought, that was the coolest thing ever. How do I do that? How do I do that? After a couple of weeks of searching, I found this, WinNuke 95, written by this author, Mr. Burnt Bogus of the Den. And I thought this was so cool, and all of a sudden I have this superpower. I can do all sorts of crazy things. And Windows 95 Service Pack 2 came out, and my superpower was gone. Now, I'm not malicious. I don't want to crash people's computers, but there's something pretty intoxicating about being able to control some type of system that you're not supposed to be able to, right? Something you're not supposed to have access to. And I figured, could I make WinNuke 96? Could I make the next version? And that's when I got into reverse engineering, understanding memory manipulation, reading things like FRAC and 2600. And I've then spent the rest of my life trying to figure out how to do that. How can I exploit systems, and how can I patch them, and then how can I exploit that? And that brings us to Hackaday, where I've learned so much from all of you. In fact, it was, I threw the badge in my X-ray machine last night. Thanks, Sam, for the recommendation on the X-ray machine. So this is the Hackaday badge from, that you're all wearing. And it was a few years ago, 2019, I was talking to Sam Zalouf, Adam Zalouf. What a coincidence, last names and the same domains, weird. And also Alex Whitmore, who's doing a talk right now. In fact, actually, you can kind of hear in the other room if everyone cheers. So let's cheer for Alex, and then afterwards, I'll just tell him that was for you. Let's go, yeah! Woo! Go Alex! Yeah! All right. He's gonna ask, why were you guys cheering? It was for you. What? Oh my God, hi Alex. Oh, well, I hope you enjoyed that. That was all for you. So we're, that's funny. We're just chatting about different projects that we're all working on, and one of the concepts I have many concepts, very few finished projects. And one was this thing someone handed me, and they said this was a USB condom, or neuterer. So what this thing does is, this is a device that you plug. Let's say you want to charge your phone in the airport, and you don't trust the airport charger. So you plug your phone into this with USB, and it cuts off the data lines and only allows power, so you're only charging. Okay, that's a good idea, but how do I know that this opaque device actually is not containing something else, like a chip that's doing something crazy? So that'd be a good idea if I made transparent ones, and I gave those out to people. But that's not that very, very fun. Really, what I want to do is I want to make a transparent one where there's 2 wires for power, 2 wires for data. You see the data lines stop because they're copper, fully transparent. And then I use indium tin oxide, a transparent conductor, to continue the traces for the data. And because USB is actually high speed, when you have a high speed line and you put another, let's say, just wire coming out zigzagging, you now have an antenna. So you'd actually have a fully transparent USB neuter that's really just radiating all the information. So I thought that would be cool. So I got this stuff from ITO on plastic sheet PET from Adafruit. I tried cutting, I tried making a couple versions. It was just super obvious that there was something really, really fishy. So I thought, okay, how do they make a ITO? Like, I don't know, how can I just make it myself? Can I make it at home and then I can make a really nice version? So I Googled how to make ITO, and I was like, why does Google tell us how fast the search is? Like, we know you're the best, Google. Like, no one's saying, let's Bing it. We say we Google it. So, and then I realized, oh, applied science. That guy is amazing. Ben Krasno, he has everything, a lot of these things I search, it's usually just him coming up with how to do this stuff at home. So pretty incredible. He has a talk at 6 p.m. today I'm excited for. And I watched his video, and he has this thing called a vacuum chamber and a vacuum pump where he's sucking air out. So I'm like, okay, I got to get one of those. I go on eBay, I get this thing. This is a dual stage rotary vane. We'll figure out what that means later. I had no idea. I just got what he got. And I turned it on, and I started having oil just going everywhere in my kitchen. Like, what is this? So I look up what I need. I need this oil mist filter. So, okay, Amazon, $157. So I just use a toilet paper roll. Which this was actually early COVID, so the going price of a toilet paper roll is about $157, if you recall. And I'm now trying to just figure out how does all this vacuum stuff work. I'm seeing all these videos on Sam Zalouf's channel. I started recently watching this guy, Nick Poole. I know he's here, and I've been watching his channel recently. Really amazing stuff there as well. And I also continue watching Ben's videos, and he does something really cool. He makes freeze-dried ice cream, like with a vacuum chamber. I'm thinking, okay, some of my projects will take me a long time. Will take months, years, whatever. So I try doing that. So I actually get like a vacuum chamber. I mean, do I have like a... so I have my vacuum pump going into this 4-line trap. That's just to stop, let's say, water and things from getting back. And then I have a cryo trap. This is like propylene glycol. It's the stuff that you get in those packs of cold when you get something in the mail. And then that chamber has ice cream. And I'm heating it a little bit. And what's really interesting about this is, all right, so we know water. Water generally boils at 0 degrees Celsius and generally freezes at 0 degrees Celsius and generally boils at 100 Celsius. But that's only true in atmosphere. And what that means is really, this is called a phase diagram. So really there's water and when it becomes a solid, when it becomes a liquid and gas, but there's also pressure. So if you change the pressure, you can do some cool stuff. So you can actually go solid, turn it to ice, and then you can lower the pressure and then get down to a gas, and that's called sublimation. So you can turn a solid into a gas without ever going into water or liquid. If you've ever seen dry ice, you see it just gassing off, right? That's sublimation. So that's one way that you can actually make freeze-dried ice cream, so I thought that'd be really cool. And you may hear different things like atmosphere or torr, but don't worry, it's really easy to figure out all this pressure stuff. All you have to remember is 1 atmosphere is equal to 1.0132 bar, which is equal to 33.8985 feet of water, which is equal to 29.9213 inches of mercury, which is equal to 406.7825 inches of water, which is equal to 101.325 kilopascals. Which is equal to 14.6955 psi, which is 760 torr, or millimeters mercury, and 1.0332 kilograms for squared centimeters. Unfortunately, everybody uses all of these different things, so it's really hard to calculate, but just memorize that, you'll be good. So fortunately, I made some type of freeze-dried thing. It looks gross. It was absolutely amazing. Super, super rich. Unfortunately, in that process, I then destroyed my vacuum pump. So now there's all this water. I'm like, okay, I need to open this up, figure out how this works. And they have security screws on the vacuum pump. Like, they're trying to prevent people from opening the vacuum pump. Around the same time, my friend Stan had said, hey, I have this mill that I'm giving away if anyone wants. It's just in the back of my trunk, hardly used, like new. Unfortunately, that's the mill. So, like, yeah, I could use a mill, so I take it home, and I try a couple different methods, and EvapoRust is absolutely amazing. I don't work for EvapoRust, but that thing, like, I put stuff in EvapoRust, I took it out the day later, there's nothing really beautiful. Did a great job, and this is now the mill. Unfortunately, I was left with a couple of fasteners. I still don't know where those go. But then I use the mill. I have a small lathe, the Grizzly, a G0765. Took a piece of steel, cut a little bit and just tried to cut into that security screw, and fortunately I was able to just generate something to actually open that thing. So I opened it up, I cleaned it out, and that's when I learned what a rotary vane is, which I think is kind of interesting. Here we can actually see what's happening. So I'm just manually holding this with a drill. Those two white things are the vanes, and rotary just means rotation. What's happening is, like, if you were to take something and push a balloon, you're going to push that air out. Well, it's like pushing air out, and while that other side is expanding, it's just like if you were to breathe in, you're expanding, and that air will just go into your body, for example. Then I start getting closer and closer to sputtering. So this is my attempt at a magnetron sputter. So I'm now copying more of Ben's videos and other things. And now I have high voltage. I'm using a microwave oven transformer. I'm using an auto transformer from the wall. So I take 120 volts and I control that 0 to 120. Then I go into a microwave oven transformer, which ups it like another 70 times. I go through a high voltage diode, and then to these two sides, that's a steel plate. That's just some like NPT, I don't know, connectors. And I'm pulling vacuum on this entire thing up there with high voltage, and now it's spraying metal, or it's spraying electrons, hitting it hard enough that it's spraying metal and sputtering this thing. Unfortunately, it's still not doing ITO, indium tin oxide. I need better vacuum for that. But anyway, I go back to, all right, well, this USB thing, see how we're on time. All right, cool. So let's understand first, why are there two data lines with USB? And that's because the USB lines are actually differential. And what that means is that you have, if you have used an Arduino, you might set a pin as high, just let's say 5 volts or maybe 3.3, depending on your VCC, or ground, 0. But really, now if there's electrical noise, if there's like interference somewhere, then what you might end up experiencing is a slight variation, might be 4.8 volts. But the Arduino, the transistors inside don't care. They'll still see that as 1 or high. Now, the nice thing, now if there's a lot of interference, it might actually go low. You might be able to take a floating pin and go high, or a ground pin and go high. So the nice thing about an inverted or differential signal, like in twisted pair, like in Ethernet, is you have two voltages offset by something, and all you're looking at is the comparison of these two voltages. And then if there's interference, they both will get interfered, and the difference between these two is still the same. And we can actually kind of see interference. I remember a long time ago, I was sitting at my desk, and I had these speakers on my desk. I'm not sure if this will work, but we'll test real quick. And I remember I got a text message, and the speakers on my computer were making noise. I'm like, wait, why is that? Kind of hear that? So these are not connected to anything. So that's called interference. Anyone from the FCC here? Just curious. So that's interference. I thought that's actually pretty amazing that you can produce sound on a speaker that's not even connected to anything. Or if it is connected to anything, you're not actually touching it. You're literally wirelessly emanating sound into this thing. You're not using sound, you're using RF. I thought that is so cool. Like, what else can I inject sound or noise or information onto? And I thought about keyboards. I was really interested in keyboards. So I started taking a look at some general wireless keyboards at first. Several years ago, I created this project called KeySweeper. It's basically a stealthy Arduino-based device. It looks like a charger. It's actually inside of an Adafruit charger. It has a PHONA board, which talks to GSM. And whenever it's near a wireless charger, it sniffs and decrypts the keystrokes and then produces an online interface you can go to, and you can start typing on the keyboard wirelessly. Fortunately, the FBI released a notice saying there's this wireless keystroke logger disguised as a USB device charger, and they have the excellent additional best practice to prevent a compromise. Limit which outlets are available for device charging. All right, so don't let people plug stuff in. Know whose chargers are currently being used. And immediate removal of an unknown charger. So I think I might make a new one with a banana, like put it inside of a banana. What they don't realize is the circuit inside can go in anything. It doesn't have to be a charger. So soon it'll be limit which bananas are available. Know whose bananas are currently being used, and immediate removal of an unknown banana from the office. Okay, so I thought, all right, wireless keyboards, that's interesting. That makes sense if you can attack the wireless communication. There's already RF between your computer or a USB dongle and the keyboard itself. But what about a physical keyboard? Inside of a keyboard, you have something called a scan matrix. Basically, if you have 100 keys on a keyboard, you don't want to have 100 pins on your microcontroller. So it's better to use a scan matrix where you can actually share pins. And the interesting part about this is that there's also diodes on every pin. That prevents key ghosting. So I thought, okay, well, in a keyboard, if you actually look at the keyboard, the wires are all different lengths. So could I just measure all of the wire lengths? And what is the length of a wire? Well, for one, all conductors are antennas. And what is the wavelength of an antenna, or the frequency? It's related to the physical length of a wire. So if you measure all of those, then you actually now know the wavelength, the resonant frequency of every single key on a keyboard. So could I inject that? I'm not sure if that would work. And just to learn a little bit more about RF, so I started doing this, and I found it was not working. I got a little bit of luck on a mouse, but once I got to, let's see where we're at. All right, cool. All right, once I got to trying to inject on my keyboard, it wasn't working. So like, okay, I don't really understand what's happening. If I touch my oscilloscope to the keyboard itself, I now change everything about the way that I change the impedance, and I can't measure it that way. So I actually have to really probably just understand RF better. So one thing that I started to learn was RF. This is a highly scientific chart from XKCD about the electromagnetic spectrum. So radio frequency RF is just one part of the electromagnetic spectrum. And I think that's actually really helpful to understand because visible light, the light that we see, is also part of the electromagnetic spectrum. So it's actually helpful for me to think about basically all radio waves as light. Right? I can now think of everything as light, and all waves have the same properties. They have reflection, they have absorption, refraction, diffraction. And as I'm learning about radio waves, they also have very clever names like low frequency, medium frequency, high frequency, very high frequency, extremely high frequency, I'm sorry, ultra high frequency, super high frequency, extremely high frequency, and then far infrared. And that's when you get to infrared, and then light, visible light, ultraviolet, X-rays, gamma rays, etc. I don't know if there's anything after that. But that's pretty interesting. So I'm trying to learn about this, and okay, I want to understand, if I want to understand how a packet works, or if I want to understand some networking, I want to understand how a packet works. If I want to understand Ethernet, then I need to understand, or Cat5, I need to understand voltage. So here I need to look up how RF works, which is how electromagnetism works, which is how light works. So I start looking up what light is, and that just starts talking about photons on Wikipedia. I'm like, wait, what's a photon? And then I start reading about this thing called wave-particle duality, and this is just like blowing my mind. So apparently, like I always thought of light as these particles, right? These little dots that you can fly and send. This is called, this right here is called the double slit experiment. So this is a double slit. This was in my living room. I took a plain laser, green laser. I go through this double slit here. I would expect to see two lines on the end, on the other side of the room. Instead, we see this like up, down, up, high, low, high, low, high, low. That's called an interference pattern. So literally, the laser going through that two lines creates this pattern. What does that mean? And now another way to thinking about this, and people have done great demonstrations of using water. Like if you actually have a water wave go through a dam, and you have two slits in that dam. Now two new waves will come out, and then they'll interfere. And those waves, they have peaks and troughs, right? So now those peaks and troughs will interfere. Veritasium did a good job of explaining this, so he has a video that you can check out. So now I'm fascinated by optics and that this stuff can actually work. So I start looking online and like, how do I do optics experiments at home? I find 3D, like you can find optomechanical equipment you can just 3D print at home and start building, buy your lenses or mirrors from Thor Labs, Edmund Optics, online, eBay, wherever you want. And I'm really curious now about this photon thing because there's another thing with the double slit experiment with, like let's say we have light, like let's say we're sunglasses, and let's say they're the aviator type or very reflective, and 50% of light goes through, 50% of light reflects off. What happens when you send one photon to your sunglasses? Does it go through or does it reflect? That's actually a pretty interesting question. So there's actually a lot of research that's been happening 30, 40 years ago about what happens with single particles like photons and electrons. What happens when they interfere, when they do one thing. And apparently, supposedly, they do both. This is called the quantum superposition. Now, this is blowing my mind even more. So what actually happens is supposedly it will go through both. It will reflect and it will go through. And how do you know that? And you know that because, according to papers, when you reintroduce them through another, let's say, beam splitter or sunglasses, you can then you'll actually see it on one side of a beam splitter. If one side is blocked, you'll actually end up seeing it on the other side of the beam splitter if the actual photon went that direction. There's papers on this. We won't get into this. If you can't, fortunately, there's lots of open papers that you can access online. But there's something called the Elter-Weidman bomb tester experiment, which also was first a thought experiment around this. And it said that if you created a photosensitive bomb that would explode when it detected a photon, you can, in some cases, detect that there's a bomb there. It will explode if the photon ever gets sent. And you can learn that that is there without ever having a photon actually hit it. This is pretty amazing because this could mean that could you do the same thing with an X-ray? If an X-ray is a photon, then couldn't you split an X-ray in two, hit a human with a superposition, the X-ray continues down another path, you remerge them, and then you now learn information. This is called which path information. Did it go this way or not? So I'm like, all right, I have to try to understand some of this quantum stuff. I don't know if I can, but I'll try. So I start looking, what experiments can I do at home? And I find this book called Exploring Quantum Physics Through Hands-On Projects. Like, that sounds amazing. And I look up the authors, David Prucci and Shani Prucci, and I find that Shani did a Supercon talk. Actually, he's done a couple Supercon talks. So I just tweeted at her immediately. I was like, oh my God, I'm your biggest fan. And we started chatting, and I got the book, and I just started going through some of their experiments. Like, this is actually really cool. I really do suggest this book because you can do a ton of stuff at home. It's really, really incredible. Because if people are doing quantum mechanical experiments 30 years ago, 40 years ago, think about how much technology has progressed since then and what we're able to do at home. So now I'm learning about phototubes. Phototubes are actually super interesting because they're extremely simple. All it is you, let's say, a piece of glass and you have two pieces of metal inside and there's vacuum. And if light of a certain energy hits it, so if you have, let's say, blue light or ultraviolet light hit something like zinc, it will then emit electrons. And those electrons will hit the other piece of metal and then conduct a current. And now you have a current. And if you send, let's say, red light instead, you get nothing. If you send 1,000 times the red light at the same time, you get nothing. And that just showed that light was also at times quantized. So we saw it as a wave when we did the double slit experiment, but now we see it as single particles with some amount of energy. So this is absolutely crazy. I want to make one of these. How do I make a phototube? So it's glass, it's metal. Well, I can just make pieces of metal. Like, I can take pieces of metal and cut it or bend it. But I don't know how to mess with glass. So I start Googling, how do you make glass? Like, how do you actually, I don't know, make phototubes? So I find this book called Building Scientific Apparatus, and amazingly, it's on archive.org for free. So you can access the full book there. There's a full chapter working with glass. So this is very exciting. The properties of glass, what you need, tubings, rods, etc., and the glassblower's tools. So I get the very basic tool set. So this is a national torch, and then you need a fuel. I use propane. You also want oxygen for borosilicate. You want borosilicate glass, like Pyrex. And the reason for that is that you're going to use a lot of heat, and you don't want the glass to break. It's easier to use in some cases and harder to use in some cases. Anyway, I was like, I'm not going to pay for oxygen. Like, I breathe oxygen every day. Can I just, like, take it? And apparently, most of the air is actually nitrogen. Something like 80% nitrogen, maybe 19% oxygen, something like that. So you can actually get one of these oxygen concentrators. So this, if you have emphysema, you might have one of these, or you can find them on Craigslist. And I was looking, like, can I just produce the oxygen myself? And I found more actually people on a Discord called Vacuum Hacksaws helped me and said, oh, this is all you need to do. Get an oilless compressor, so that you're not spitting out oil, which takes in the air, compresses it, and then you put it through a couple of things. You put it through a silica gel, like a desiccant, that gets rid of the humidity. Then you put it through a couple of particulate filters, just to get rid of any dust or anything. And then you put it through something called a molecular sieve. And this is actually the same thing as the silica gel that you might find in your vitamin packets, right? That silica gel, how does that work? It's really just these balls of silica, and they have holes in them on the outside, kind of like a golf ball. And those holes are the size of water molecules. So it's really adsorbing, AD, not absorbing, but adsorbing. And you can do that. You can get other things called other sieves, like zeolite, and there's various kinds that will actually collect or adsorb different gases. So you can say, I want to collect nitrogen. I want to adsorb nitrogen so the oxygen then continues to go out. And then you can put that in a buffer tank, and then you can compress that further if you want and spit it out to whatever you want. So you can just make oxygen at home, or nitrogen. So now I have everything, and I have made fire. It's absolutely amazing. So now I'm continuing, and I'm just trying this stuff at home. I'm trying to make these different connections and like T's and ring seals, and every time I make something, I'm like, I kind of got it. Half an hour goes by, and I hear it break in my kitchen. Like, okay, what am I doing wrong? And I try it again, and I try it again, and it just keeps breaking. So then I'm like, okay, well, maybe I need to go take a class or something, and after literally weeks, every weekend I would just spend trying to make some glass. I just went chapter by chapter by chapter in this book. And the second to last chapter says annealing. Even when a seal is carefully blown out to give it a uniform wall thickness, harmful stresses are inevitably frozen into the glass. Worked glass must be annealed by heating to a temperature above the annealing point. So I learned I was doing it wrong the whole time. I need to anneal. So I continued now, I tried annealing, and I still found that a lot of things that I was doing weren't working. So I then found a local class on lamp working and glass blowing in LA. So I went to this class. Unfortunately, they're doing soft glass. I had trouble finding anyone who would teach how to do borosilicate or scientific glass blowing. So I went to this class anyway. I learned a few things, but my stuff at home still didn't work. So I continued to search online, scientific glass blowing, borosilicate glass blowing. Can I find anyone who's doing this kind of thing that I could just pay to teach me for a few hours, right? It's the same thing as a class. I found this guy on Instagram. He has a lot of beautiful glass work. He also had like a lot of oregano or basil or something in a lot of his images. I think he likes, yeah, not sure. But I asked him, it's like, you can't really come to my shop. I just started messaging more and more people on Instagram, on Google, on YouTube. Then I just went to LinkedIn. I searched scientific glassblower. And I just started messaging, literally copying and pasting my message to everyone. Most people didn't respond. Some people were like, you can't come to where my work, and I can't teach you, right? I have a job, a scientific glassblower. And finally, I get someone who responds. This person works at Sigma Aldrich, owned by Merck. Legit company. It's been a scientific glassblower for a long time. And she says, oh, I see that you're in LA. We're located in Milwaukee, Wisconsin. Is this something that you're thinking you would travel here for? It's time to check in. And the great thing is that tickets to Wisconsin in the middle of winter are super cheap. I think they paid me, actually. And I arrived. I was very excited to get to this place. And now here's the thing. I think she was very suspicious. She was like, okay, well, is this guy legit? You're gonna have to send me, 6 hours up front. Pay me up front. I was like, that sounds reasonable. So I sent her the money via PayPal, got the ticket, flew out there. I show up, knock on, I get an Uber. I stayed at a hotel, and I show up and I say, knock on the door. Old woman comes to the door and says, hi, is Katie or Ian there? She's like, nobody here by that name. I'm like, what? I check the address. I'm like, is this the address? She's like, yep, that's the address. I'm like, oh no. And I call Katie. I have her phone number. We've never spoken before. I've just given her money on the internet. And I'm at this address. And she's like, oh, I have the number switch. Sorry. Hold on, come outside. And I see her 10 houses down. I'm like, okay. Whew. It was so cold. I was so cold. I live here in LA, and I thought, okay, I'll just bring 4 layers, and that doesn't do it. It's the wrong kind of layers. I guess you need a windbreaker or something. I don't know. It was freezing. So I show up at this shop, and I'm so excited. So these 2 guys, Ian and Katie, and they're incredible. So they're teaching. This is Ian's workshop. This is his home workshop, and he has this glass lathe, absolutely amazing. Makes it really easy. Just a few pictures of their lab here. This is a pretty sweet, this is a torch that Ian made. So this is fully glass besides the 2 needle valves. So one needle valve allows you to put in something like butane, and then one allows it to go out, and then it uses the Venturi effect to add additional air through the back, and you get this torch, and that's super sweet. And this is Katie and her lightsaber. And the blue or the purple haze, that's actually basically the neodymium glasses that you wear to see much better, and it removes all of the yellow sodium flare when you're working. So when you're glass blowing or lamp working, you really want to wear that. So you can see better. So this is if you ever want to reach out to them, if you want to fly to Wisconsin, they now teach personal classes. And while I was out there, I realized, I've been talking to this guy on Twitter, Mikhail Katz. He's a professor and I realized, he's in Wisconsin. So I said, hey, he's an optics professor. He has an optics lab out there. I'm like, can I take you to lunch? He's like, yeah, come by. Also, my wife is Jennifer, Dr. Jennifer Choi, Professor Jennifer Choi, and she has a quantum lab. I'm like, wait, I'm going to go visit an optics lab and a quantum lab. So I got to go hang out with them and, of course, Professor Toby. And just blew my mind. I haven't gone to a school or university, so I haven't seen the types of stuff that they're doing. This is a magneto-optical, a MOT, not a microwave oven transformer, magneto-optical trap where they're actually able to cool down atoms, neutral atoms, with a laser and trap it. That blows my mind. So I fly home, really reinvigorated on this glass blowing stuff, and I'm thinking I need to do little projects as I'm working on progressing on larger projects. So I thought it'd be cool. Maybe I do a little art project. I make a little neon sign or something, because I think I can do that now. I think I understand enough about vacuum and gas and glass blowing, and actually neon signs are they're called gas discharge tubes. So neon signs, what that means is that there's neon inside. most of the tubes you see don't actually have neon inside. So some are helium or argon or krypton or xenon. So typically the noble gases. And sometimes you can add things like mercury vapor, and that will also alter the color. So we can see a couple of the colors here. So that's pretty interesting. Like, oh, that'd be cool to have a neon sign on my wall. Like, it could actually just be the noble gases like argon, neon, etc. And how does that work? I was just curious. So the way what my understanding is, when you have a neon tube, you have two metal electrodes, and then you're putting high voltage on those. I assume it'll work with both DC and AC, but I think AC will actually look better. And what it's producing is this huge electric field. Now, huge electric field, if there's ever any electron in there, that electron is going to get pushed by that field or pulled. And if that electron hits a neutral atom, like an atom of neon, that neutral atom's not doing anything, it's just hanging out. And if it hits it hard enough, well, what will happen is an electron will fly off. And if that electron flies off and then joins another atom that has already had an electron fly off, light is produced. That energy gets converted to light. Now, you need that electric field, you need the vacuum because you need enough space for that electron to actually traverse. So I think of it like, if I'm in a parallel parked car and I just slam on the throttle, I'm just gonna hit the car in front of me slightly. But if I'm on the street and I have a lot of space and I accelerate, I'm going to gain more and more speed. Right? Force is equal to mass times acceleration. My mass is the same, but I'm accelerating. So I'm going to have a lot more force when I finally hit it, and I'm going to eject the person from that car. And they're going to hit another car. And as long as they're in a magnetic field and they're wearing like a steel suit, they're probably going to eject someone else, and the whole thing will keep going. So I thought, well, it'd be really interesting if I could actually have this on my wall and not have wires, because I don't like wires. So I try to remove any wires on the walls, like, I don't want my TV or Xbox or whatever wires. So I remember that I saw a fluorescent tube light up a long time ago, and that's from a Tesla coil. So I got one of these like little Tesla coils on Amazon, and I'm like, start Googling, like, how do these work? What's a Tesla coil, and can I make my own? And as I'm Googling, I find out this guy, Jay, who I had the opportunity to meet last night. So check out his channel. He's also doing a talk tomorrow at 11 a.m., so I'm pretty excited about that. So learning a lot about Tesla coils from him. Also go on to a Discord for Tesla coils, talking to a bunch of people. I meet someone named Tate, and we're chatting on Discord.
Oh, hell nah! I did not just get the plasma toroid! Let's go, dude!
So he comes over.
My god!
So Tate's here. So he recorded this in my home. He's he's working on Tesla coils, like crazy mad stuff like this. And he needs equipment. I'm like, just come over whenever you want and use my equipment. Don't destroy my oscilloscope. And oscilloscope still works. So he's doing crazy stuff. So I'm excited to just be around that type of energy. This is his channel. Check it out. As you can see, he's doing incredible stuff. Also, a shout out and thank you to Scotty for pushing me to actually do this talk here, because I wasn't going to. But we hung out and he convinced me to. So excited for his stuff. So I started learning about something called a Slayer exciter circuit. And this is actually really, really interesting. This is the simplest circuit, so that's very helpful for me. I'm not an electrical engineer. So this is my Slayer exciter. It's no different than many others. This is just a bypass capacitor that's to store energy, so we can ignore that for now. And just understand, like, briefly what's happening. Basically, VCC, that's our voltage. There are I put in, say, 12 volts. 12 volts can go through this resistor, R2, and then go through the base of that transistor. There's an NPN, and NPN transistor is just a switch, right? It turns on or off. So voltage going to the base turns it on, which allows current to go from VCC, from our battery or whatever, through that inductor, L3. Now, whenever you have current, whenever you have a charged particle moving through something, it creates a perpendicular magnetic field. So now there's a perpendicular magnetic field like going around this inductor. An inductor is just a coil like this. So now that happens, the same thing reverse happens with L4. L4 now says, I feel this magnetic field, and produces a current. And that current actually then shuts off the base, which then turns off L3, which then turns off that field, and now you get this oscillator, this natural oscillator, which is really, really cool. I thought, okay, maybe I can put like a Tesla coil in my wall, and then I can light up the neon sign, and I won't have electrodes in the neon sign. They'll just be lit. And then I asked Sam, someone I work with, hey, do you know of like any way that I can do a flat Tesla coil? And he's linked me to this. Thank you, Sam. That's him hard at work. So we find this flat Tesla coil, and that makes a lot of sense. So this is called a pancake coil, where you essentially have your primary coil on the outside here, and the secondary, which is here I have about 140 turns to 1. So what that means is if I put 1 volt in, I'm going to get about approximately 140 volts on the outside. I used Eagle. I found a ULP to create spiral coils. It only got up to 100 turns, so you just go into the code and you literally make it 200, and now you can go higher. I tried producing them at home. I tried ferric chloride. I used like spray paint on PCBs, and that wasn't working. And it was around this time that I'm messing with this project that Crash Space had a Wearable Wednesday with our favorite Liz here. She's also doing a talk today, 5 p.m. here. Excited for that. Actually, that's Wearable Wednesday is where I met Deborah at Geek Mom Projects. And she's a machine. I don't know if you've seen her Twitter. She just has so many amazing projects. She is absolutely a machine. Like literally just a cybernetic organism with living tissue over metal endoskeleton. So I was like, it would be cool to have some type of a wearable thing for Wearable Wednesday. So I thought, okay, instead of, I could put that PCB inside, I don't know, I could like have a Tesla coil with me, but could I make it on a flex circuit? What is a flex circuit? Well, a flex circuit is just capped on tape, not Capcom tape, but capped on tape, and capped on tape with copper. That's all really a flex circuit is. And I started messing around, can I make this at home? I started Googling, like, what is capped on tape? It's a polyamide tape. And this website says that the polyamide tape has a strong taste and a sour smell. The polyamide tape is likely to be fake. So that's how you know if you have fake polyamide tape, by the taste. Thank you, hopelightcn.com. So I tried a couple things, but finally I went to PCBGoGo.com. I sent them my board. They sent me this. Actually, I think I have one. So this is now, I think, as far as I know, the first flexible wearable Tesla coil. Then I now need to make like an actual ampule or something to actually carry a gas. So I've now been improving my vacuum setup. I'm using all these NPT gauges, but I have a ton of leaks. And then I've now switched to KF. So NPT, these are just like things you use for pipe fittings. KF is quick flange. It's just it's a better, higher vacuum connector for all these connections. Basically, this is a scroll pump. I got rid of the oil pump. I just didn't like dealing with all this oil. So now scroll pump, I go through a valve. I can turn on or shut off the vacuum. Goes through this like four-way this cross. I can bring it to atmosphere. I have a valve that's now going to that balloon. That's my breath. So I just blow into the balloon. Put my breath in there. I have desiccant there to remove humidity from my breath. And that way I can now pump my breath. I can pull vacuum from a piece of glass at the bottom here. The MKS 901P, that's just it's a pressure gauge, the pressure sensor. And then I just break out serial and I have a little analog voltmeter on there so I can see the voltage. So I can basically pump down, pull out all of the air from this glass tube. Then I can turn off the vacuum, or actually prevent anything else from being pulled out, and then I can open up that needle valve and allow my breath to go into this, and I can control the pressure because it's a needle valve and I'm monitoring the pressure there. And then I can use the Tesla coil near it to see, will it light up? And once I do that, here's the full setup. And so I have basically a scroll pump. I have the book right next to me. I have very little space to cook eggs anymore, but that's okay. Who needs a kitchen? This was the first successful actual ampule, and I think because I had put my breath in there, Sam insisted that I had blew myself. I'm not sure that's entirely true, but that's what he says. And that's actually, let's see if this thing works. Don't mind the giant heatsink in my pocket. So here we have like the actual ampule, as you can see. And here's like a different one. Might be hard to see on the. Take it off. Right. No batteries, nothing else. It's just a piece of glass. Different gases will produce different. And I know you'll really want to see what's down there. So that's all you need. Little coil, and just some quick things. Here I took a little FLIR camera. I was just curious to see like what it looked like. You can actually see this toroidal or donut shape. What's interesting to me is that it really only lights up at the edges. So you can kind of see, like in the center it will not, but down here it will. I thought that was pretty interesting. And also, this is just while making it. So here another, you can kind of see the shape a little bit of that field, which is which I think is kind of cool. Just the rest of the components used, I just took 3 lithium cells, 18650 batteries, put a battery management circuit on it, because I kept putting lithium cells without battery management circuits, and I'd wear it for a couple hours. The voltage would go down to like 2.5 volts, and then I'd destroy the battery. Just kept doing that because I was lazy. I use a voltage regulator. There's a buck regulator. And that basically takes my voltage. Let's say you have 3 cells, you'll be at, I don't know, 12.6 volts or something like that. That brings it down to something like, I bring it down to about 10 volts because unfortunately I have to have this giant aluminum heat sink with a transistor on top. So that's in my pocket and it's just getting hotter and hotter and hotter. And that's the rest of it. It was just a Slayer exciter with these 3 components, and thank you so much for coming. All right.